Imagine a cube 6 miles across, deep and high, and that's how much lava came out.
Rocky Mountain officials have issued a dire last warning about an imminent and potentially catastrophic eruption. Recent seismic activity and rock slides have heightened fears of a volcanic disaster that could reshape the landscape and threaten lives. What has triggered this alarming alert? How severe could the impending eruption be? Brace yourself as we move into the latest developments, uncover the science behind the warnings, and reveal the shocking truth about the future of the Rocky Mountain region. The Rocky Mountains, one of North America's most iconic mountain ranges, have a history that stretches back millions of years. Their formation is a tale of immense tectonic forces at work. About 80 million years ago, during an event known as the Laramide orogeny, the Rockies began to rise. This period was marked by intense tectonic activity, where the Pacific plate is subducting beneath the North American plate. This collision caused the Earth's crust to buckle and fold, creating the towering peaks we see today. But tectonic activity wasn't the only force at play. Volcanic activity also played an important role in shaping the landscape of the Rockies. Ancient volcanic eruptions spewed lava across the region, contributing to the diverse geological features we observe now. These volcanic layers, combined with sedimentary rock deposited by ancient seas, have given the Rockies their unique and rugged appearance. Among the key geological features of the Rocky Mountains are its prominent peaks and expansive valleys. These include famous landmarks like Long's Peak in Colorado, which stands at 14,259 feet, and the intense valleys carved by glacial activity. Ancient lava flows and volcanic rock formations tell a story of a tumultuous past, marked by dramatic geological events. But how did these features come to be? The ancient lava flows we see today are remnants of volcanic activity that occurred millions of years ago. These flows, along with sedimentary deposits, were later uplifted and exposed by tectonic forces. This combination of volcanic and tectonic activity has created a landscape that is both breathtaking and complex. Throughout its history, the Rocky Mountain region has experienced significant geological events. Notable earthquakes and volcanic eruptions have periodically shaken the area, leaving lasting impacts on the landscape and ecosystems. For instance, the Yellowstone caldera, located in the Rocky Mountains, is a supervolcano that has erupted with cataclysmic force in the past, reshaping the region each time. These historical geological events have molded the physical landscape, but also influenced the ecosystems within the Rockies. The aftermath of volcanic eruptions, for example, created fertile soil that supported diverse plant life. Earthquakes, on the other hand, have occasionally altered river courses and affected wildlife habitats. But what does all this history mean for the present? The recent seismic activity and rock slides in the Rockies have raised alarm bells. Could the geological forces that shaped the Rockies be stirring once again? The officials' warning about a potential eruption brings a new urgency to understanding the region's geological past. How prepared are we for another significant geological event? As we journey into the ancient past of the Rockies, we reveal the clues to potential future threats. The dynamic dance between tectonic upheaval and volcanic fury has sculpted this awe-inspiring mountain range. Yet it also serves as a severe reminder of the untamed forces lurking beneath. What ominous signs might foretell an impending disaster? And more importantly, how can we safeguard ourselves against nature's next colossal strike? The answers could spell the difference between catastrophe and survival. Recent events in Yosemite National Park have raised alarms and captured global attention. Two massive rock slides occurred at El Capitan, one of the park's most iconic formations, drawing hikers and climbers from around the world. Tragically, one person was killed and many others were left in shock. These incidents weren't isolated, but part of a troubling pattern of increasing geological activity. The rock slides were sudden and devastating. Huge slabs of granite, weighing thousands of tons, broke away from the cliff face and plummeted to the valley floor below. Eyewitnesses reported hearing a deafening roar as the rocks tumbled, followed by clouds of dust that filled the air. The sheer force of the slides caused trees to be uprooted and trails to be buried under debris. What caused these rock slides? Experts point to a combination of factors: prolonged weathering, freeze-thaw cycles, and seismic activity all contribute to the weakening of rock formations. Over time, cracks develop and expand, making the rock more susceptible to breaking away. The recent earthquakes in the region have likely accelerated this process, acting as the final trigger that caused the rock to give way. But these rock slides are just the tip of the iceberg. Recent seismic activity in the Rocky Mountain region has officials and scientists on high alert. Over the past few months, there have been several notable earthquakes, each increasing in magnitude and frequency. These tremors are not random, but part of a worrying trend that could signal something much more dangerous. One of the most significant earthquakes occurred on April 14, 2024, with a magnitude of 4.2. The epicenter was near the southern edge of Yosemite Valley, a popular area for visitors. This quake was strong enough to be felt throughout the valley, causing the ground to shake and unsettling many tourists. Just a few weeks later, on May 6th, a more powerful quake with a magnitude of 4.6 struck near the park's western boundary. This tremor was felt even more widely, shaking buildings and causing items to fall from shelves. The most alarming quake happened on May 25th, 2024, with a magnitude of 4.8. Its epicenter was near the northeastern part of the park, close to Tuolumne Meadows. This quake was the strongest yet and was felt throughout Yosemite and even in areas outside the park. The shaking was intense and lasted nearly 30 seconds, causing significant concern among visitors and officials alike. What do these earthquakes mean for the future? The increasing magnitude and frequency of these quakes suggests that the region's geological activity is intensifying. Scientists believe that this could be a precursor to a much larger event, possibly a volcanic eruption. The tectonic forces that created the Rockies are still at work, and the recent seismic activity could be a sign that these forces are building up once again. The correlation between recent earthquakes and potential volcanic eruptions is a cause for concern. As the tectonic plates shift and grind against each other, they create stress and pressure that can eventually lead to an eruption. The recent rock slides and earthquakes are likely symptoms of these underlying geological processes. Recent events have prompted Rocky Mountain authorities to issue a series of official warnings. These warnings are not issued lightly and reflect a growing concern among experts about the possibility of a catastrophic eruption. The details of these warnings are major for understanding the gravity of the situation and the potential risks involved. Rocky Mountain officials have identified several specific areas as high-risk zones. These areas are particularly vulnerable due to their geological makeup and recent seismic activity. Among the high-risk zones are parts of Yellowstone National Park, known for its geothermal features and historical volcanic activity. Officials have urged visitors and residents in these zones to remain vigilant and follow safety guidelines. Statements from geological experts and park officials paint a severe picture. Dr. Laura Williams, a leading seismologist, emphasized the unusual patterns in recent seismic activity. "We are observing a significant increase in both the frequency and magnitude of earthquakes in the region," she noted. "This is not typical and indicates that the tectonic stresses in the area are intensifying." Park Ranger Michael Harris echoed these concerns, urging visitors to heed all warnings and stay informed about the latest developments. The geological indicators of an imminent eruption are becoming increasingly apparent. One of the most telling signs is the rise in seismic activity. Over the past few months, the number of earthquakes has surged, with many exceeding magnitudes of 4.0. These quakes are not isolated incidents, but part of a disturbing pattern that suggests the Earth's crust is under significant stress. The frequent tremors are a clear warning that the geological forces at play are reaching a critical point. Ground deformation is another key indicator. Satellite imagery and ground-based sensors have detected notable changes in the Earth's surface. Areas within the Rocky Mountains are experiencing uplift and subsidence, signaling the movement of magma beneath the surface. This ground deformation is a precursor to volcanic eruptions, as it indicates that magma is pushing upwards, creating pressure that can eventually lead to an explosive release. Gas emissions are also providing critical clues. Scientists have recorded elevated levels of sulfur dioxide and carbon dioxide in the air. These gases are typically released from magma intense within the Earth. An increase in these emissions suggests that magma is rising and degassing, a clear indicator of volcanic activity. The changes in gas concentrations are being closely monitored, as they can provide early warnings of an impending eruption. Thermal anomalies are being detected as well. Advanced satellite imagery has revealed hotspots in several areas of the Rockies. These anomalies indicate rising temperatures beneath the surface, often associated with the movement of magma. The heat is causing changes in the landscape, melting snow and ice in some regions, and creating new hot springs and geysers. These thermal signals are yet another piece of the puzzle pointing towards a potential eruption. But what does all this mean for the future? The combination of increased seismic activity, ground deformation, gas emissions, and thermal anomalies paints a concerning picture. The geological indicators are aligning, suggesting that the Rocky Mountains could be on the brink of a significant volcanic event. The warnings from authorities are clear. The risk is real, and the need for preparedness is more urgent than ever. When considering the potential consequences of a volcanic eruption in the Rocky Mountains, it's compulsory to investigate both the best-case and worst-case scenarios. Understanding these possibilities can help us prepare for what might come and mitigate the risks. In the best-case scenario, we might see a minor eruption with limited impact. Such an event could involve a relatively small release of magma, resulting in localized lava flows and minor ashfall. While this would still cause some disruption, the damage would be confined to a small area, and recovery efforts would be manageable. The affected regions could see temporary road closures, minor property damage, and brief interruptions to daily life. Historical comparisons show that smaller eruptions, like the 1980 eruption of Mount St. Helens, can still be significant, but are typically less devastating than larger events. On the other hand, the worst-case scenario involves a major eruption leading to widespread destruction. This type of eruption could release massive amounts of magma, ash, and gas, causing severe damage over a broad area. Entire communities could be buried under ash, and pyroclastic flows could devastate large swaths of land. The destruction of infrastructure, such as roads, buildings, and utilities, would be extensive, leading to prolonged recovery efforts. The 1815 eruption of Mount Tambora, which caused widespread devastation and global climatic effects, serves as a historical example of how catastrophic such events can be. The impact on local communities and infrastructure would be intense. Roads could be rendered impassable by lava flows or buried under ash, hampering evacuation efforts and emergency response. Buildings might collapse under the weight of accumulated ash, and utilities like power and water supply could be severely disrupted. Evacuation plans would face significant challenges, especially in densely populated areas. Ensuring the safe and timely evacuation of residents would require meticulous planning and coordination. The economic impact of a major eruption would be substantial. Tourism, a significant source of revenue for the region, would plummet. National parks and natural attractions would be closed, leading to a loss of income for local businesses that rely on tourist traffic. The long-term recovery costs would be enormous, with funds needed for rebuilding infrastructure, restoring services, and supporting displaced residents. The ripple effects would be felt across various sectors of the economy. Ecologically, the consequences would be equally severe. An eruption could destroy habitats and displace wildlife, leading to a loss of biodiversity. The immediate aftermath would see charred landscapes and lifeless areas where vibrant ecosystems once thrived. Over the long term, the changes to the landscape could alter watercourses, soil composition, and plant life. These disruptions could also create new geological formations and opportunities for scientific research. The regeneration of ecosystems in the wake of an eruption offers a unique chance to study ecological resilience and adaptation. The potential for new geological formations is another intriguing aspect. As magma cools and solidifies, it can create new landforms, such as volcanic domes and lava plateaus. These new features add to the geological diversity of the region and provide valuable insights into the Earth's processes. Scientists can study these formations to learn more about volcanic activity and its impact on the environment. So what does this mean for the future of the Rocky Mountain region? The potential consequences of an eruption are massive and varied, impacting everything from local communities to the broader ecosystem. The best-case scenario offers a glimpse of hope, while the worst-case scenario serves as a severe reminder of nature's power. How can we prepare for such a monumental event? In light of the recent warnings from Rocky Mountain officials, preparedness and safety measures are more significant than ever. Visitors to the region must be equipped with the knowledge and resources to protect themselves in the event of a disaster. First and foremost, understanding evacuation routes and emergency protocols is necessary. National parks and local authorities have established clear evacuation plans that visitors should familiarize themselves with. These routes are designed to guide people to safety swiftly and efficiently in the event of an eruption or significant seismic activity. It's required to follow posted signs and listen to park rangers or emergency personnel who can provide real-time updates and directions. Staying safe during an earthquake or volcanic eruption requires quick thinking and adherence to safety tips. If you find yourself in the middle of an earthquake, remember to drop to the ground, take cover under sturdy furniture, and hold on until the shaking stops. Avoid doorways and move away from windows or anything that could shatter. If you're outdoors, find an open area away from buildings, trees, and power lines. During a volcanic eruption, protecting yourself from ash is critical. Wear masks and goggles to prevent inhaling ash particles and shield your eyes. Stay indoors as much as possible. And if you must go outside, cover your skin to avoid irritation from falling ash. It's also important to have an emergency kit ready, including essentials like water, non-perishable food, first aid supplies, flashlights, and extra batteries. Following official guidance and staying informed can make all the difference. Keep a battery-operated radio handy to receive updates from local authorities and emergency services. Social media channels and official websites are also valuable sources of information during a crisis. Regularly check these platforms for the latest news and instructions. Local communities are taking significant steps to prepare for potential disasters. These preparations involve coordinated efforts between government agencies, non-governmental organizations, NGOs, and community organizations. The goal is to ensure that everyone, from residents to visitors, is as safe as possible. Government agencies play a crucial role in disaster preparedness. The United States Geological Survey and the National Park Service are continuously monitoring seismic activity and other geological indicators. They provide significant data and forecasts that help inform public safety measures. Local governments are also involved, developing and implementing emergency response plans that include evacuation procedures, communication strategies, and resource allocation. NGOs and community organizations are equally imperative in these efforts. Organizations specializing in disaster relief and environmental protection offer support and resources to bolster community preparedness. They conduct training sessions, distribute educational materials, and assist in creating comprehensive emergency plans. These groups often provide financial assistance and supplies to help communities build resilience against natural disasters. Resources available for residents and visitors are extensive. Many parks and local governments offer workshops and training on emergency preparedness. These sessions teach participants how to create emergency kits, develop family communication plans, and understand local evacuation routes. There are numerous online resources, including checklists, guides, and instructional videos designed to help individuals prepare effectively. But how can these measures make a tangible difference in the event of a disaster? The combined efforts of government agencies, NGOs, and community organizations ensure a well-rounded approach to disaster preparedness. By staying informed, following safety guidelines, and participating in community efforts, individuals can significantly reduce their risk during a natural disaster. In the face of increasing seismic activity and the looming threat of a volcanic eruption, ongoing monitoring efforts are more critical than ever. Organizations like the United States Geological Survey are at the forefront of these efforts, utilizing advanced technologies to keep a close eye on the geological heartbeat of the Rocky Mountains. The United States Geological Survey, along with other scientific organizations, employs a variety of sophisticated tools to monitor the region. Seismographs are strategically placed throughout the Rockies to detect and record the slightest ground movements. These instruments provide real-time data on earthquake activity, helping scientists identify patterns and potential precursors to larger events. Satellite imagery is another important tool. High-resolution images from satellites allow researchers to observe changes in the landscape, such as ground deformation, which can indicate magma movement beneath the surface. This bird's-eye view is key for spotting early warning signs that might not be visible from the ground. Gas sensors play a significant role in monitoring volcanic activity. These sensors measure the levels of gases like sulfur dioxide and carbon dioxide, which are often released by rising magma. An increase in these gases can signal that an eruption is imminent. By continuously tracking gas emissions, scientists can provide more accurate forecasts and warnings. Thermal cameras are used to detect heat anomalies. These cameras can identify areas where temperatures are rising, often a sign of increased volcanic activity. By monitoring these hotspots, researchers can gain insights into the movement of magma and the likelihood of an eruption. Recent findings from these monitoring efforts have been concerning. Data shows an increase in seismic activity, with more frequent and stronger earthquakes shaking the region. Ground deformation measurements indicate that parts of the Rocky Mountains are experiencing uplift, a clear sign that magma is pushing upwards. Gas emissions have also been on the rise, and thermal cameras have detected new hotspots. All these indicators point to heightened geological activity. Experts are now making predictions about the likelihood and timing of a potential eruption. While predicting the exact timing of an eruption is challenging, the patterns observed suggest that the risk is increasing. Dr. Emily Johnson, a leading volcanologist, has stated, "The data we are seeing is consistent with a region that is gearing up for significant geological activity. While we cannot say with certainty when an eruption will occur, the signs are there, and we must be prepared." Future plans for monitoring and research are focused on enhancing our ability to predict and respond to volcanic events. The United States Geological Survey and other organizations are investing in newer, more advanced technologies. This includes deploying more seismographs and gas sensors, improving satellite imagery capabilities, and developing more sophisticated thermal imaging systems. One exciting area of advancement is the use of drones. These unmanned aerial vehicles can be equipped with a variety of sensors and cameras, allowing them to fly over and around volcanic areas to gather data that would be difficult or dangerous to collect otherwise. Drones provide high-resolution imagery, thermal data, and gas measurements from locations that are otherwise inaccessible. Another promising development is the improvement of computer models that simulate volcanic activity. These models use data from past eruptions and current monitoring to predict future events with greater accuracy. By continuously refining these models with new data, scientists hope to improve their predictive capabilities. As we look to the future, the combination of ongoing monitoring, advanced technology, and cutting-edge research will be important in understanding and mitigating the risk posed by the Rocky Mountains. The dedication and collaboration of scientists, government agencies, and local communities are key to staying ahead of potential disasters. Understanding the potential consequences of a volcanic eruption in the Rocky Mountains can be better grasped by looking at historical case studies. Two of the most significant volcanic eruptions in history, Mount St. Helens in 1980 and Mount Tambora in 1815, provide valuable insights into what might happen and how we can prepare. On May 18, 1980, Mount St. Helens in Washington state erupted catastrophically, marking one of the most significant volcanic events in U.S. history. The eruption was preceded by 2 months of intense seismic activity, including numerous small earthquakes and steam venting episodes. This buildup was a clear indicator that something massive was about to happen. The eruption itself was sudden and devastating. A 5.1 magnitude earthquake triggered a massive landslide, the largest in recorded history, which in turn released the pressure within the volcano. The resulting lateral blast flattened everything within a 230 square mile area. Ash plumes rose 15 miles into the atmosphere, spreading across the United States and affecting air travel and weather patterns. The immediate impacts were catastrophic. 57 people lost their lives, and hundreds of homes, roads, and bridges were destroyed. The local ecosystem was severely disrupted, with countless animals killed and huge areas of forest obliterated. The ashfall affected crops and livestock far beyond the immediate vicinity, leading to significant economic losses. There were significant long-term impacts on the surrounding community and environment. The area surrounding Mount St. Helens underwent significant change, offering a singular chance for ecological study and regrowth. Over the years, scientists have observed how life slowly returned to the area, providing insights into ecological resilience and recovery. The lessons learned from Mount St. Helens led to significant advancements in volcanic monitoring and preparedness. The incident made clear how critical early warning systems are, as well as how important thorough emergency response preparations are today. Seismographs, gas sensors, and satellite imagery are standard tools for monitoring volcanic activity, helping to provide earlier warnings and more detailed information. The eruption of Mount Tambora in Indonesia in 1815 is one of the most powerful and devastating volcanic events in recorded history. On April 10, 1815, Tambora erupted with such force that it expelled an estimated 100 cubic kilometers of volcanic material into the atmosphere. The eruption was heard 1,200 miles away and produced pyroclastic flows that devastated the surrounding area. The immediate impact was catastrophic, with approximately 10,000 people killed by the eruption itself. The global climatic effects of Tambora's eruption were even more far-reaching. The massive amount of ash and sulfur dioxide released into the stratosphere caused a volcanic winter, significantly lowering global temperatures. 1816 became known as the year without a summer, characterized by severe climate anomalies that led to crop failures and food shortages worldwide. The impact on human populations was devastating. Tens of thousands of people died from starvation and disease as a direct result of the climatic changes. The historical significance of Tambora's eruption extends beyond the immediate loss of life, as it influenced agricultural practices, migration patterns, and even cultural and literary works of the time. Comparing these historical eruptions to potential scenarios in the Rocky Mountains helps us understand the magnitude of what could happen. Like Mount St. Helens, a Rocky Mountain eruption could have immediate, devastating effects on local communities and ecosystems. And similar to Mount Tambora, the broader climatic impacts could be significant, affecting regions far beyond the immediate area. These historical case studies underscore the importance of monitoring, preparedness, and international cooperation in responding to volcanic threats. As we continue to improve our understanding and technology, the goal is to mitigate the risks and protect both people and the environment from the potentially catastrophic impacts of volcanic eruptions.